Okay, welcome to this video that goes through a series of homework questions sent through. Question 7, a stone is projected vertically upwards from a height of 2 meters. Its height above its starting position, d at time t seconds after launch, is given by d equals 13 plus 2 plus 30.2t minus 4.9t squared. At the same time, a second stone is projected upwards from a height of 2.3 meters. Its height above its starting position is given by 13t minus 4.9t squared. For how long are both stones simultaneously at least 4 meters above the ground? Okay, so we know that the first stone is projected 2 meters, so it's already 2 meters above the ground, and the question is looking for 4 meters above the ground, so it's already above it. Its height above its starting position is d1. Okay, so here for the first one, the d1 position. So this is our d1. So essentially here we're looking for the point where d1, to get to 4 meters, we want d1t to be greater than 2 for our starting position. So essentially we create an equation which is 2 is equal to 13.2t minus 4.9t squared. So the goal here, why we've done that, is because we can find, so what will happen is that the projectile will start from here and will fire upwards and down, and at this position here, this is our D1 position, so it's going to be 2 meters above the starting position and 4 meters from the ground. So we're going to find two t values where that corresponds to. So we're going to find that first. So let's rearrange our equations. We get a quadratic, so move everything over to the left hand side. We get 4.9t squared minus 13.2t plus 2 is equal to 0. And then on your calculator you're going to solve this directly. So you just go to equation of function, polynomial, second degree, and then plug your values in. So 4.9 minus 13.2 plus 2, and you get a t value of 2.53 and a second t value of 0.161, and that would give you your value. So that gives you your t value essentially. So so essentially at this point here, at t1 is going to be 0.161, and at the second point d1 is going to be at 2.53. So in that range, your first particle is above 4 meters, and then we're told a second particle is done, and we need to. So that one is 2.3 meters above the ground. So for this one here, we say again. So this is 2.3 meters, and again we want to find they're both 4 meters above the ground. So for this one, for 4 meters, we do 4 minus 2.3, which is just equal to 1.7. So this value here, let's call this D2. So our D2 value is going to be 1.7, because remember, the D2 measures its height from its starting position, so it's already 2.3 meters up, so we need to do 1.7. So at this position here, we say that DT2 is equal to 1.7 meters, and again we solve to find where does this cross, where is this, the t values essentially, the minimum t values where this occurs. So we plug in the same values, and then we rearrange. So it's 4.9t squared minus 13t plus 1.7 is equal to 0. And again we plug this into our calculator to solve. So again we go to the equation of functions, polynomial, and then 4.9 minus 13 and 1.7. So that gives us a t value equal to 2.515 and t equals 0.1379. Okay, so between these two values is where this one's above 4 meters. So this, so above 4 meters is between these two, and for our original value, so that was for D2, and for D1 above 4 meters is going to be t equals 2.53 and t equals 0.161. So we need to occur when they both are above 4 meters. So when this one is above 4 meters, this one is not, because 1379 is lower. So we have to wait for 0.161 for it to be above 4 meters. So that's when it starts to be above 4 meters. And then it goes below 4 meters first in this one. So this particle drops below 4 meters first, 2.515. So here, the question states for how long are both stones simultaneously above 4 meters? Well, it's going to be when the first particle just drops below 4 meters at 2.515, or is at 4 meters, and the particle when both particles are above is at 0.161. So we just substitute, we just find the difference between them to see how long they are above the air, and we find that that answer is 2.354 seconds. And that is our answer to question number 1. Okay, the next one is solve the equality x squared plus 3x is greater than 10. Find the set of values. So that's for part A. So this one, first step is correct that this person has done. We do x squared plus 3x minus 10 is greater than 0. We can then factorize this. So this is going to be x, or plug it in your calculator if you wish. So x plus 5 x minus 2 is greater than 0. So we could say x is equal to 2, x is equal to minus 5 when x squared plus 3x minus 10 is equal to 0. From here we draw a quick sketch. So we show that it crosses when it's at 2 and at minus 5. And the reason why we draw the sketch is so that we can visualize our situation, and then we can do the next step a bit easier. So we're looking here for, this represents the y values. So we're looking for when essentially the curve is above the x-axis, when we're looking at all the positive y values. So that occurs when x is greater than 2, but it also occurs when x is less than minus 5. So all values less than minus 5 will have a positive y value. So your answer you just leave like this: x is greater than 2 and x is less than minus 5. So you could write it with a union 1 if you wanted to, but it's actually probably just fine to leave your answer like that as well. Question B, find the set of x values which satisfy both the following inequalities. So the first one we got is 3x minus 2 is less than x plus 3, and then the second one is the same one that we have. So already we could say that x has to be greater than 2 and x is less than minus 5, and that's when the x squared plus 3x minus 10 is greater than 0. The next thing we need to find is this inequality: 3x minus 2 is less than x plus 3. So 3x minus 2 is less than x plus 3. We can then rearrange, so we move the x to the left hand side, the number term to the right hand side, so it becomes 2x is less than 5, and then we solve, we say that x is less than 5 over 2, so x is less than 2.5. So from here we've actually got two inequalities again. So here we know from the first one that x is greater than 2 and x is less than 2.5. So we can write that as saying x must be between 2, because it's greater than 2, but it can't be any bigger than 2.5. But also x can be is less than minus 5, because that fits into our one. So x is less than minus 5. Again, if you want to test this out, then you can plug, for example, x equals minus 10 into the equations. So 3 times minus 10 minus 2 is equal to minus 32, and that's less than minus 10 plus 3, which is minus 7. And then you can plug that into your second equation as well to get your answer. But essentially this is the set of answers that you needed for your results. The next question: by completing the square, find in terms of the constant k the roots of the equation x squared plus 4k minus k equals 0, and find the set of values for k for which the equation has no real roots. So for the first one we want to complete the square. So to complete the square, we say that this is going to be x plus 4k over 2 squared minus 4k over 2 squared minus k. So again, that's from the x plus b over 2 squared minus b over 2 squared plus c. So from here, this becomes x plus 2k squared minus 4 divided by 2 is 2. So this becomes 2 squared k squared minus k is equal to 0. And then we solve this, so it's x plus 2k squared minus 4k squared minus k is equal to 0. So then from here, we rearrange, so it's going to be x plus 2k squared is equal to 4k squared minus plus k, and then find in terms of the constant k the root of the equation. So then we square root both sides, so it's going to be x plus 2k is equal to the square root plus or minus of 4k squared plus k, and then we minus 2k, so x is equal to minus 2k plus or minus the square root of 4k squared plus k. And that's your answer to part A. And then part B, find the set of values for k for which the equation has no real roots. So for this one, for the VAT here, we use the discriminant version. So remember that b squared minus 4ac is less than 0. The equation inside the square root here is essentially the same as the discriminant. So we're going to plug that in, so it's 4k squared plus k is less than 0, because we can't have a negative square root, a negative inside a square root, so that would mean that you'd have no solutions at all. So then from here you would say, well, that's 4k squared is equal to minus k, and then you would divide through by k, or in fact you could take out a factor of k, so it's going to be k bracket 4k plus 1 is less than 0. So then you find the set of values for k for no real roots, and then from here we say that k is equal to 0, or 4k plus 1 equals 0. So 4k equals minus 1, so k equals a minus a quarter. And from here we draw this setup, so we know that it crosses at 0 and minus a quarter. So it's going to look something like this. It's still a k squared term, so it looks like an x squared. So basically it's just the same as an x squared term for 4x squared plus x, but we just replace the x with a k. And we know that it crosses, so it's 0 and minus a quarter. So the values that are negative, so essentially below the x-axis, is going to be where it's minus a quarter is less than k is less than 0. And that's your final answer for this question. The last question, the cross-section of a tunnel is in the shape of the region defined by the inequalities. Y is less than or equal to 6 minus x squared over 6, and y is greater than 0, greater than or equal to 0. On the axis below, show the region satisfying the inequalities. So for this one, if you're never sure about how to draw the graph, you should plug in, so you can plug some numbers into the equation. So if we start with x values and the corresponding y values, so we start with x equals 0, so it's 6 minus 0 squared, so 0 squared over 6, which is just equal to 6. So when x is 0, y is 6, then we plug in 1, so it's 1 squared, so 6 minus 1 over 6 squared is equal to 35 over 6. That's quite an annoying one to do, so let's do for x is, sorry, that's x is 1, but let's do x is 2 because each of these break down to in 2. So for when x is 2, it's equal to 16 over 3. So 6 minus 2 squared over 6 is equal to 16 over 3, which is 5.33, so it'll be somewhere around here. And then our next one, so x is 4, so x minus 4 squared over 6 gives an answer of 10 over 3. So that gives us 10 over 3 is about 3.33, so it looks there. And then the next one, x is 6, so x minus 6 squared over 6 gives us 0. So at that point it's going to be like that. And then if we did 8, so 6 minus 8 squared is minus 4.667, So this one is minus 14.3. So that's somewhere down here. Now, we know that y has to be greater than or equal to 0, so we don't need to worry about that. So we can say that in our first instant here, when x is greater than it, we are only interested in x values up to 6. And then in the next section we have so we've also got the negative values we need to check. So here we've got negative 2 squared, so negative 2, so sorry, x is negative 2. So if we do negative 2, that's actually going to give the same values. So that's going to be 16 over 3 still, and you can plug that into your calculator to confirm. But essentially it's going to give the same values. So when we have minus 4, it's 10 over 3. When we have 6, it's 0. So again, it's going to be the same values all the way down. So it's going to look something like this as your tunnel. So in the region below, show the region, on the x below, show the region satisfying the inequalities. So when y is less than 6 minus x squared, that means it's going to be in this region here. It's greater than 0 and y is less than x in this one. Or y is less than 6 minus x squared over 6 essentially. So it satisfies it. So when it's less than, it's below the curve. When it's greater than, it's above the curve. Given that x are in meters, write down the height and the maximum width of the tunnel. So for this one, the height of the tunnel is going to be this one here. So it's going to be 6. And the width for the tunnel, maximum width of the tunnel is from here to here, which is 12. So the height is equal to 6 meters. The width is equal to 12 meters. Using a semicircle of radius 6, estimate the cross-section area of a tunnel. So if we do a semicircle, so we're assuming that it looks something like this, where this is 6 meters. So the area of a tunnel is going to equal an area of a circle, so pi r squared over 2. So that's equal to pi times 6 squared over 2, and you can just plug this directly in the calculator. So pi times 6 squared over 2 is equal to 56.55 meters, so around about 57 meters altogether. Given that the tunnel is to be 20 meters long in length, estimate the volume of earth that we needed to remove in order to build the tunnel. So for this one, we're going to assume that the shape has a cross-sectional area of about 57 and has a length, assuming that it's got the same cross-sectional area of 20 meters. So here it's going to be area times length is equal to volume, so the cross-sectional area. Cross-sectional area is about 56.55, times that by 20, so 56.55 times by 20 gives an answer of 1131 meters cubed, and that's going to be your volume, and that should be a meter squared actually. And that is the end of these questions. If you have any further questions, please let me know.